In this lecture, we take uh, one more example on Euler's theorem of homogeneous function. The question is if u is equal to cosec inverse root over x to the power 1 by 2 plus y to the power 1 by 2 divided by x to the power 1 by 3 plus y to the power 1 by 3, then prove that x square uxx plus 2xy uxy plus y square uyy is 10u upon 12 into 13 by 12 plus 10 square u upon 12. So let us try to solve this question. We have given that u is equal to cosec inverse of root over x to the power 1 by 2 plus y to the power 1 by 2 divided by x to the power 1 by 3 plus y to the power 1 by 3. Then we have to prove that x square uxx plus 2xy uxy plus y square uyy, which is equal to 10u upon 12 times of 13 upon 12 plus 10 square u upon 12. So here we apply the Euler's reduction. So let us first define what is the reduction of Euler's theorem for homogeneous function. If z is a homogeneous function of two variables x and y of degree n and z is equal to f of u, then x del u del x plus y del u del y, which is equal to n f of u upon f dash of u, which can be also written as g of u. And second, x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square, which is equal to g of u in times of g dash of u minus 1. Now, so for this example, we have to first find out what is the value of n, f of u, f dash of u, and then after we calculate g of u, and once we have g of u, we can also obtain what is g dash of u, and if we substitute all these two values in the last expression, we are able to get this result. So let us first try to find out what is the value of n, f of u, f dash of u. From equation number 1, we have u is equal to cosec inverse of root over x to the power 1 by 2 plus y to the power 1 by 2 whole divided by x to the power 1 by 3 plus y to the power 1 by 3. Let z is equal to cosec u, which is equal to root over x to the power 1 by 2 plus y to the power 1 by 2 upon x to the power 1 by 3 plus y to the power 1 by 3. Now here, let us uh, eliminate this part, and now we have to see like this. So z is a pure algebraic function. So let us try to find out, or let us try to check that this z is homogeneous function of x and y or not. If it will be homogeneous, then the process is very simple for us. So let us try to write down here. We have to divide and multiply and divide by x to the power 1 by 2 in the numerator as well as in the denominator. Similarly, in the denominator also, x to the power 1 by 3 root over 1 x to the power 1 by 3 into x to the power 1 by 3 upon x to the power 1 by 3 plus y to the power 1 by 3 upon x to the power 1 by 3. Now, this if we remove the root sign, then its power will be 1 by 2. So x to the power 1 by 2 whole to the power 1 by 2, x to the power 1 by 3 whole to the power 1 by 2, and this x to the power 1 by 2 will cancel, it is 1. Similarly, y by x will be the root of y by x whole to the power 1 by 2. We can also write like this. And this will also cancel, it is 1. And y by x to the power 1 by 3. So this is x to the power 1 by 4, and this is my x to the power 1 by 6. It is in the denominator. So if we take it into numerator, it will be minus 1 by 6. And f of this part is nothing but function of f of y by x, whose degree is 0. So ultimately, this z is a homogeneous function of this x and y of degree If we simplify it, it is 3 minus 2 upon 12, means x to the power 1 by 12. So z is a homogeneous function of x and y of degree 1 upon 12, 1 upon 12, and z is equal to f of u, which is equal to cosec of u. So we have f of u, which is cosec of u, and the degree of the given homogeneous function is 1 upon 12, means n equal to 1 upon 12. So let us try to use the deduction of Euler's theorem to obtain our desired answer. Hence, by deduction of Euler's theorems, x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square, which is equal to g of u, g dash of u minus 1. Let us give it equation number 2. Then here g of u is equal to n f of u upon f dash of u. Since n equal to 1 and f of u equal to not 10u, it is cosec u. It is cosec u. It is cosec u. And this n is equal to 1 upon 12. So let us put all these values. 1 upon 12, n equal to 1 upon 12. F of u is cosec u, and f dash of u is nothing but derivative of cosec of u. Let us simplify once again. 1 upon 12 into cosec u. What is the derivative of cosec u? It is nothing but minus cosec u into cot u. So cosec u will cancel, and we have minus this 1 upon cot u goes to numerator, and it will become 1 upon cot u is 10u, and this is the minus sign, so minus 10u upon 12. This is the value of g of u. Now let us try to find out. So we obtained the value of g of u. Now we have to find out what is the value of g dash of u. So g dash of u is equal to derivative of minus 10u upon 12 with respect to u. So derivative of 10u is sec square u upon 12 with minus sign. But we know that what is sec square of u? It is 1 plus 10 square u, because we know that 1 plus 10 square u is equal to sec square u. So therefore g dash of u is minus 1 plus 10 square u upon 12. G of u is minus 10 u upon 12. G dash of u is minus 1 plus 10 square u upon 12. So let us try to put in the equation number 2. Then we have x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square, which is equal to g of u, g dash of u minus 1, which gives us g of, because since g of u is sin u 2u upon 2 and g dash of u is cos 2u. Let me show you. It is 1 minus 1 plus 10 square. This is again wrong. So let us correct it. This g of u is equal to this is g of u equal to minus 10u upon 12, and g dash of u is equal to minus 1 plus 10 square u upon 12. These are the two correct values. This is copied from the last example. Sorry for that. Okay, so let us try to simplify this one. So if we take minus sign outside, this will become 10u upon 12, and this is 1 plus 10 square u upon 12, and this we have taken minus sign outside, so all term will become plus. 10u upon 12, 1 plus 10 square u upon 12, and if we take the LCM, it will be 12. So this is also plus 12. So 1 plus 10 square u plus 12 upon 12. So 1 plus 12 is 13. We can write down 10u upon 12 into 13 by 12 plus 10 square u upon 12. Therefore, x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square, which is equal to 10u upon 12 times of 13 upon 12 plus 10 square u upon 12. And this is our desired result, hence proved. Thank you.